They teach this, okay. So that's what we get here. So this is what we have. So, okay, so we divided. Are there any questions on this? Now, again, I can't see the chat, so if you have a question, use that hand raise feature, please. All right, well, there are no questions. Let's do another one then. So here's another one we're going to do. Again, I figured it's good to do a few of them so we have practice. Now, again, I don't know. I don't remember. I think they teach this in high school. I don't remember for sure, though. It doesn't hurt to do practice. So what we're going to do here is we're going to take this. This is our dividend. And we're dividing it by x minus 3. And there's a mistake there, isn't there? Yeah, that should be a -7. Let me see. Okay, let me fix that quickly. Oh, I didn't put the negative in there, but let me just make it into plus. All right, there we go. Might have been -7 before, but then I figured it'd be better to do 7 because the numbers get easier. So, all right, that's okay. All right, so as before, right, what we have is x minus 3. The 3 goes here. Right, that's our a, x minus a. Okay. It's x minus a, right? So you don't put the minus here. You're going to put a minus here if this was x plus a. So this whole table thing is assuming that you have x minus a. Then we have the coefficients here. We put them in here. Right? So 2 goes here. 7, the next coefficient goes here. There's no x term, right? So what we have to do is we have to put a 0 as a placeholder. I mean, you could write this as 0x, but if you put 0 here, that's fine. Same idea. 5 goes here. That's our constant term. Then what do we do next? Well, just like before. The first coefficient is down, right? We multiply. The product goes here. And then we add. Hold on. Is there a mistake in this? Yeah, let me fix that. Hold on. Oh my goodness. Should be negative. Should have been -7. All right. Guess I forgot to put -7 in a row for some reason. So, well, fixing it now. Good. All right, there we go. Sorry about that. All right, let's try again. So anyway, that's what happens. So we have 3 times 2, okay? That's going to be 6. The answer is going to go here, as you can see. 3 times 2 is 6. 6 goes here. Then what's going to happen next is we're going to add, right? So this is the 6 from here. And we add these two. And when you do that, what you get is -1. But now the process repeats, right? So over here, as you can see, what's going to happen is you're going to have 3 times -1, which is -3. And that's going to go here. Then you add, you're adding it to 0, so that's just -3. Okay, again, same idea. 3 times -3 is -9. -9 goes here. We add 5 and -9. Okay, so -9 is here. 3 times -3, that's -9. 5 plus -9, -4. There's no columns left, right? So we stop. And since our dividend was degree 3, this is degree 2. That is, our answer has these coefficients. but it starts as degree 2. It's always 1 degree less than the one we started with. It's always 1 degree less than that. So because of that, we have 2x squared minus x minus 3, which is, of course, the same thing as this. And our remainder is minus 4. We were dividing by x minus 3, so we have this. Okay. Yeah, I'm sorry about that -7 that was missing before, so I don't know. I guess I thought I fixed it, but I didn't. Anyway, we have this. Remember, the last column here is always the remainder. And again, since we're dividing by degree 1, the divisor, the remainder will always be 0 or a non-zero constant in this case, because this is degree 1. All right, are there any questions about this? Okay. So let me fix that. Overlap each other. Okay, so here there's something different I'm doing, as you can see. Notice that we're dividing by x plus 5. Notice I'm dividing by x plus 5, okay? So because of that, what we do is we can write this x minus -5. Okay? Remember, you don't want to have it as plus here. This process is assuming that it's x minus. The divisor is x minus. So we have to make sure it's in the form of x minus. So, but that's okay. We can write this as x minus a negative. That's the same as addition. So we write it as -5. And then as before, we have to put the coefficients. What's nice about this is it's already written in standard form, which basically means it's written from left to right, decreasing powers of x, as you can see. And there's no missing terms. In other words, this is degree 3. So if there were any missing powers of x, less than 3, you'd have to have 0. That's not the case here. So we don't need a placeholder, in other words. All right, let's put the coefficients in. Here's 1, that goes here. 9 goes here. 23 is here. 15 goes here, as you can see. Okay, so what do we do next? Well, remember, this is synthetic division, right? So we're going to take this 1, and I'm going to bring it down. So this comes down here. Okay, nothing goes here. Nothing goes in this row, over in this row, this column, So the -5 times 1, you get -5, right? Down to the right, up to the right. Okay. Then we add, right? You multiply, put the entry 1 row up, 1 column to the right, add. So 9 and -5 become a 4. That's what's down here. Now, what should go here? Well, -5 times 4 is -20. So -20 should go here, and I have that. Then, as illustrated, well, as you can see already, but even if it wasn't there, you should know the next entry here would be the sum. So it's 23 minus 20, or plus -20, which is 3. Okay. Now we have 1 column left, right? You keep going until you get to until you complete the last column. Complete it this way, so to say. So here we're going to have -5 times 3, which is -15. Then we have -15, and 15 is 0, as you can see. Okay, so again, the whole process was -5 times 1 That's -5. That goes here. We add and get this. Okay. Right? We had -5 times 1, right? That's the product. That product goes here. And then we add, right? Then we have 4 times. Then we had, excuse me, I made a mistake. Let me just fix that. There we go. And then you repeat the process, right? You know, you do, and I don't want to keep drawing because that's going to get messy. We have -5 times 4, -5 times 4. That's -20. The product goes here. The sum goes here. 23 plus -20. Notice here we get a remainder of 0. So in this case, remember, this is our f of x, right? This is our dividend. This is degree 3. The quotient will be degree 2. And this is where the quotient comes from. These are the coefficients. So we have x squared plus 4x plus 3. That's our quotient. Not only that, our remainder is 0. So if we were to write it out as in the division algorithm, we would have our f of x here. Let me actually write that in. We would have f of x, right? Right? That's going to be our d of x, which is, again, in this case, x plus 5. For synthetic division, we wrote it as x minus 5 over here, times our quotient, q of x. And r of x in this case is 0. So just like with integers, we can see that we get a factor. In other words, x plus 5 is a factor of this thing. And so altogether we get this. Now this should also tell you something else. Not only are we able to get a factor of this, we could keep on going. We know how to factor this thing, don't we? You have seen that before. I mean, I didn't write it out, but you theoretically could keep doing this. So polynomial division is very useful regarding factoring. And this is something else. This is actually supposed to lead to, what do you call it, the remainder and factor theorem. You could probably see it from here as well. But if I replace x by -5 here, notice that by direct calculation, I'm going to get 0. By direct calculation, I'm going to get 0, which is equal to the remainder. In other words, what I'm trying to get you to see is, I don't know how successful this is, but I'm trying to get you to see this theorem, the so-called remainder theorem. Let me just stop the recording.